Hello. I was charging an old phone today and it looked like it was charging at a linear rate. So I thought it would be a great example to use to look at graphing lines and also using Desmos to get a regression equation. So I'll show you my data here. At 8:30, I plugged in the phone and its charge was at 3%. And then I took a shower, so I missed 8:40. But then every 10 minutes after that, I checked the charge percentage, and it seemed like it was increasing at a roughly steady rate. So I'm going to make a table in Desmos and input these values, and then we'll look at the graph and go from there. So I will share my screen. This is Desmos, DESMOS.com. And I'm going to go to the graphing calculator. And if I go up to the plus here on the left, I can make a table. So that's where I'm going to start because I have a bunch of ordered pairs. And instead of the time 8:30 in the morning, I'm going to start at time 0 and then count up from there. So at time 0, the charge was 3%. I'm not going to bother with decimals or percent signs here. Then 20 minutes later, it was at 19%. After 30 minutes, it was at 28%. After 40 minutes, it was 36%. And after 50 minutes, it was 44%. And at that point, I said, all right, it's time to make a video about this. So if we look at the graph here, you can see one of the points. So I'm going to change my axes so that we can see more of what's going on here. So the x-axis is the time. I'll leave that at -10, just so I have a little bit of a margin on the left, but I'll make this go up to something more than 2 hours. Let's say like 150 minutes. And for the y-axis, I'll leave a bit of negative space down below here. This is the percent charge, so I want to go up to at least 100%. So maybe I'll do 105. And there, I've got a good look at the points. I'll click on the wrench again to hide that pop-up. And so it looks like they're roughly linear. And what I can do is make a regression equation here. So I'm going to use the variables y1 and x1 that I see in the table. So I'll just type y1, and Desmos knows to make that a subscript. And then I'm going to use the tilde that's way up in the left of your keyboard there. So instead of equals, I'm going to use this symbol, and then I'll do mx plus b, but I'm going to use ax plus b because that's the way the alphabet works. And I have to remember to make the variable x1. So I'm talking through it, but if we just just have me type it there, we've got y1 is related to ax1 plus b. And if you're familiar with r and r squared values, you know that if they're very close to 1, then you have a really strong correlation there. So this is a very, very strong correlation. And so it's telling me the slope here is about 0.82, and the y-intercept is right around 2.9. And so that y-intercept makes sense based on what we have, because it started at 3%. And there it's clicking on the line. I don't know whether I can get it to click on that green point. If I zoomed in, then maybe I could. But anyway, we know it started right around 3%. And then you can see that the line here is really close to all of these points. It looks like it's passing right through some of them, and it's a little bit off. If we had not made this regression equation, we could instead look at the values in the table. Sorry, just getting my drawing tool ready here. And we could figure out the slope here, that as we increase by 20 minutes, the charge increased by 16%. And then we increased another 10 minutes, the charge increased by 9%. So that's a little bit off. because 16% in 20 minutes would reduce to 8% in 10 minutes. So that one is a little bit off. But then if we continue here, as we go up 10%, this goes up, 10 minutes, this goes up 8%. And as we go up another 10 minutes, this goes up 8%. And I have to say, I wasn't really careful when I looked at the clock. I was looking at my clock radio in the bedroom, and it doesn't have seconds on it. So when I checked this after 20 minutes, was it exactly 20 minutes, or was it like 20 minutes and 50 seconds? I'm not sure. And similarly with the percents, had it just changed to 19% right before I looked at it? Or was it at 19% and then it was going to change to 20% just after I stopped looking at it? So these numbers aren't exact, but we have a really close to a linear relationship here. And you can see that the slope is usually here 8/10, the rise over the run. The change in y over the change in x would be 8/10. You could reduce that, but that's saying that every 10 minutes, the charge went up by 8%. So if I graph a line based on this information, y equals mx plus b, well, my slope will be 8/10. I could reduce that. I don't feel like it. Times x. And then the starting value was 3%. So then I'll have plus 3 on the end here. And you'll see the two lines are pretty close to each other at the beginning, but the farther out we go, the difference in slope means that the regression equation we got, it has a steeper slope, 0.82-ish. So it's increasing more rapidly. And what you might be interested in is how long will it take for this to charge up to 100%? We could graph the horizontal line y equals 100 and get a couple of predictions here. According to the regression equation, it will take about 118 minutes. That's very close to 2 hours. And according to our estimate, based on a slope of 8/10, it'll take about 121 minutes. Again, a little bit more than 2 hours. So if, and it's a big if we can assume it's charging linearly throughout the entire charge up to 100%, it should take about 2 hours for it to charge fully. I'm going to be in the middle of a class 2 hours after this started, so maybe I can take a little break during that class and go check on it. So there you go. We could also use point slope form. This video is just going to be a mishmash of different things, so I'll delete that stuff that I drew there. I'll hide some of these things here. If we want to use point slope form, we can use our same slope. We'll have y equals 8/10, but then we will have x minus some x value. So I have to pick one of these x values, kind of at random. I'll pick 30 and 28. Why not? Then the x value is 30. So we'll have x minus 30 in the parentheses, and then we'll have plus 28 outside the parentheses. And you can see that that is a tiny bit higher up than the line that used the essentially used 0.3 for the point. And so this one has a y-intercept at 4. So it's just 1% higher on its charge estimate there. And if I switch this to 20 and 19 instead, if I switch to that point, I'm pretty sure it will go down 1 unit and it will be amazing. So if I change these numbers to 20 and 19, boom, now it's exactly on the original line because those first 2 points were lined up nicely where it went up 16% in the course of 20 minutes. But then there was a little hiccup between 20 and 30 minutes. But then afterwards, the last 3 data points all line up nicely with each other. So it's kind of like we have two lines here. I'll use the last pair there, 50 and 44, to demonstrate again. If we use 50 and 44, this lines up with when we used 30 and 28. Because again, this is going to say the y-intercept is 4. If I could click on it. There we go. Okay. So there, you got a little y equals mx plus b, some slope-intercept form action, and then we have some point slope form action. And you can see that we get 2 lines that are pretty close to each other, but it really depends on which pair of points you choose, because not all 5 of these ordered pairs lie on the exact same straight line. I guess maybe that's how you can trust that I didn't make up these numbers, because if I'd made them up, I would have made them all perfect, right? Maybe. Okay, well, maybe in 2 hours or after 2 hours, I'll check this and I can report back to you and tell you in the description whether it really did charge to 100% after 2 hours. So that is the end of this fine video. Thanks for watching, and I'll see you another time.